IM2 classes. Today we're putting together all of our right triangle stuff. We're going to be solving right triangles. So we'll be using Pythagorean theorem, triangle sum theorem, and right triangle trigonometry, the SOHCAHTOA stuff. So let's get right into it. We are going to find all the missing pieces here. So the missing pieces that we need to find, let's just go ahead and talk about that, and then we'll set a plan of what we're actually going to be doing. So we have to find side length C here, right? And then there's two angle measures that we don't know. There's X and Y, I'm going to call them. So that's X degrees and Y degrees. So we have to find those three missing parts. How we go about it, it's going to be kind of up to you. But what we're going to do, we'll start with the side length. To find the side length, you either need to know a side and an angle that's not one of the angles, so you can use SOHCAHTOA, or if you know the other two sides, we can just use Pythagorean theorem. So let's just go ahead and do that on this side. First thing I'm going to do is label the sides A, B, and C. It's nice that this triangle labeled the C for us as C. This is the longest side, so that'd be C. So this would be our A and B. All right. So again, I'm going to use Pythagorean theorem. A squared plus B squared is equal to C squared. Remember the thing to remember about C squared, the Pythagorean theorem is the longest side always has to be C. It's not always the side you're trying to find. It's the longest side. Anyway, is going to put this in. So A is 3, B is 2, and C is C. 3 squared is 9, plus 2 squared is 4, is equal to C squared. So that's 9 plus 4 is 13, is equal to C squared. To solve for C now, you need to take the square root of both sides. The directions here say round decimals to the nearest tenth. We'll go ahead and follow the directions. Normally, I would just say just leave it as the square root of 13. But we'll follow the directions that they have in here. So square root of 13 is 3.6. Why not? 3.6. Great. So now we need to find one of these angles. Doesn't matter which angle we do first. I will go ahead and I'm going to use a different color that I'm doing this. I'm going to do this blue. I'm going to find X first. Why? That's just, we labeled it X. So I'm going to draw my eyeball. The eyeball at X is looking at the opposite side. The longest side here, this is the hypotenuse. That means the side left over is the adjacent side. Now to find X, I'm going to use SOHCAHTOA. SOHCAHTOA. All right. So it doesn't actually matter which side length, since I know all three side lengths. It doesn't matter which trig function I use, but I'm going to use the ones with whole numbers. So I'm going to use 2, which is the opposite side. I'm going to use 3, which is the adjacent side. So which trig function uses opposite and adjacent? That's going to be tangent. So I'm going to do tangent of X is equal to the opposite, which is 2 over the adjacent 3. To solve from here, I need to do the inverse tangent, both sides. So I take the inverse tangent. Make sure your calculator is in degree mode. But what we got here, so the inverse tangent cancel each other out. Inverse tangent of 2 over 3, 2 divided by 3, that comes out to 33.7 is rounded, 33.7. Great. So I'm going to go ahead and bring out the eraser. I'm going to write that in there. And then the next thing we need to do is find Y. So we can use trig again. We can use tangent of 3/2 if we want, or we can use the triangle sum theorem. So let me switch up my colors again to find y. I know that all three of these angles, so 33.7 plus that box means that's 90 plus y needs to add up to 180. So we can do this one as well. So 33.7 plus 190, that's 123.7 plus y is equal to 180. And then 180 minus 123.7 is 56.3. Oh, so let me do the algebra here first. So I'm going to subtract 123.7 from both sides. So that cancels out, and I get y is equal to 56.3. So there are missing pieces. We have the 3.6 for the side length, 33.7 degrees for one missing angle, and 56.3 degrees for the other missing angle. So 56.3. There we go. So we found all the missing pieces using three different methods to solve it. So, and really it's up to you. There's some things that you have to use, like the only way to find C with the information given to us would be to find Pythagorean theorem or use Pythagorean theorem since we did that first. But if we found an angle first, we would then have enough information to use trigonometry, SOHCAHTOA on all of it. So you can, you have options is what I'm trying to say. You can kind of find the missing pieces any way you want. Let's do another example where it looks like we're going to have to use some trig. So first thing I'm going to do is find angle G here. That's going to be the easiest thing. So we'll call it X degrees, right? So 25 degrees plus 90 degrees plus the X degrees all need to add up to 180. 25 plus 90 is 115 plus X is 180. Subtract 115 from both sides. And you get X is equal to 65 degrees. Yes. So first one, that missing point there, easy to find, 65 degrees. Now, we need to find G and H. We have options here. I'm going to find H first. So let me box that. With H, I'm going to use trigonometry. I'm going to draw my eyeball here at the 25. Label the side lengths here. So the eyeball is looking at the opposite side. The longest side here, the 13, is going to be the hypotenuse. And that means this is the adjacent side. So from there, I'm going to find different side lengths. So remember, it's going to be SOHCAHTOA. So using SOHCAHTOA, what side lengths do I know? Or what side length do I know? I know the hypotenuse. The 13 is the hypotenuse. I'm looking for the H. That is the opposite side. So which trig function uses opposite and hypotenuse? That is going to be sine. So I'm going to set up my trig function there. So it's going to be sine of 25 is equal to the opposite H over the hypotenuse 13. Solve this real quick. All I need to do is multiply both sides by 13. So 13 times the sine of 25 is 5.5, rounding to the nearest tenth. So 5.5 is equal to H. Now from here, again, I still have options of how I want to handle this. Now that I know this side here is 5.5, I can use Pythagorean theorem to find HJ. Or I can use trigonometry again. Actually, yeah, it should have. But instead, so let's do, um, I'm just going to use SOHCAHTOA again because I think that's a little bit faster, at least for me. If you want to use Pythagorean theorem, you are welcome to do that. But so for this now, instead of the, actually, I'm going to highlight in a different color. Instead of knowing, instead of finding the opposite, I am looking for the adjacent now. So let's light green. Sure, light green. So I know the hypotenuse and I'm looking for the adjacent side now. So which one uses opposite or adjacent hypotenuse? That's going to be cosine. And we'll use purple again. So it's going to be cosine of 25 is equal to h over 13. And now to solve this one, I'm going to multiply both sides by 13. So 13 times the cosine of 25, that comes out to 11.8 rounded. So 11.8 is equal to h over 13. Nope, not h over 13. That's just, and it's not even h. What am I thinking? Oh boy. Yeah, the adjacent, what you guys caught this? It's G we're looking for, not H. And so G is 11.8. So 5.5, 11.8. And that'll do it for us. See you guys next time. I think we're working on a new chapter, talking about circles or something.